So, all right. So let's continue on with this idea of independence and start with this example 2 here. So here you have a fair, well-shuffled deck of 52 cards. It consists of 4 suits. The suits are clubs, diamonds, hearts, and spades like normal. There are 13 cards in each, so we're just explaining the deck of cards again. Which of A or B did you sample with replacement, and which did you sample without replacement? So we're just talking about which with replacement and without. So suppose you pick 4 cards, but do not put any cards back. Your cards are blah, blah, blah.
It's already independent.
Yeah, so you do not put any cards back. Did I replace them?
No.
No. So this is without.
What are all these little extra, like, oh, that's the Queen of Spades one and blah, blah.
Yeah, they're telling you what they pulled. Telling you, we don't put they should say, we got these, and then you can say maybe, no. I don't know how I would say this. I don't like this question, but I'm going to go through it. So suppose you pick 4 cards and put each card back before you shuffle the next card. So put it. So this is with replacement, yeah. But it's good to associate those two.
Okay.
Independent, right? So this is independence versus dependent as well. So the first one is dependent, and the second one is independent. Well, that's all we're looking for there. I'm not really going to ask that on test. Let me move on. Talk about
something kind of random-ish, but it's about this.
Yeah.
Never mind. Let me get my questions together and then I'll ask it later.
Yeah. Okay. So mutually exclusive events. So another idea. So we have these 2. That's it, really. It's not. I'm not going to go over the list of 20. Okay. So it's just really these 2 ideas that we have to consider when we're dealing with probability problems. Mutually exclusive events are events that exclude each other from happening. So my go-to method is Republican and Democrat. Nothing. So right, if I pull somebody out and they tell me they're Republican, that excludes them from being Democrat. Those are mutually exclusive events. We can go to Venn diagrams too to explain it. Mutually exclusive events. Let me just do it down here. All right. If events A and B are mutually exclusive, I'm not talking about this A and B down here. So another A and B. Let me use E and D. So, oops, thank you. There we go. So these are mutually exclusive events. I'm just going to put ME. Those are mutually exclusive events, but if there's any overlap, anything that both sets contain, all right, this is my E, E, D. If there's anything in between that they share, then they're not mutually exclusive.
So if there's anything in between that they share.
Okay, this is how we visualize it. So we need to think of Democrat versus Republican. We'll have many other events that exclude each other. So like if you are a student who is in the statistics course, that would exclude you from taking another statistics course at the same time, right? Those are mutually exclusive events. You wouldn't be taking 2 statistics courses at the same time. Whereas taking another course like a speech class or something, you could totally be doing that, right? So those don't exclude each other. All right. So let's go through an example. Talk about that. So, I forgot to mention it. So, yeah, so there is something important here. I don't want to point it out. So, if I, what do I want to say? So, let's do that one. So, using that Democrat-Republican idea, what is the probability that I pull somebody and they are both a Democrat and a Republican?
Like in real life? I mean,
Yeah.
or ideally.
In real life.
I don't think that's possible, is it? You
Possible?
can only
No, so
play
like,
one set.
and a Republican. Are you a Democrat and a Republican?
Like as a registered
No,
voter?
you can't be both.
Right.
You choose one or the other, right? Kind of thing. So maybe you can sway in between. Maybe you have leanings in between.
Right, I'm like,
but
I'm all
we're not gonna count all those other things. Yeah, I'm just thinking of those two events.
Okay.
You can't be both. So if you can't be both, what's the probability of getting somebody who's a Democrat and a Republican? Zero. So this is an important feature to the idea of mutually exclusive events, is that we have the probability of the two with the and statement between is 0. There's no way to have both occur at the same time. So. All right, so let's go some more examples and try and make more sense of this stuff with independence and mutually exclusive. So for example, suppose the sample space, we have a sample space of 10 numbers, so you can think of rolling a 10-sided die. There are these, right? Different dice, right? Dungeons and Dragons, you know, these got these different dice out there. So say we have one with 10 sides. So if we have one with 10 sides and maybe we want an event where we get 1 through 5. So those are good ones for A. All right, for B, it's 4 through 8. And C is 7 through 9. So these are our little events, right? Maybe I want A to occur in a certain outcome. Maybe I want B to occur in a certain outcome. Maybe I want C. I don't know what. Right? We're not justifying that reason. So let's get the sets down. So what is A and B, a new set? What is in combined? What is in both? So 4 and 5. So I got 4. Let me erase that green. Look at that, the eraser. I'm using it.
Look at that. Look at you go.
So excited. All right, so 4 and 5 are the only things. I hate that the rest of B's down here, but I have no other things that are in B that are in A.
Right.
So 4 and 5 is the new set of A and B. So I have 2 things in there, which means I have 2 out of a total of 10 things, chances. All right. I'm rolling this 10-sided die. I have 2 shots out of 10 total possibilities. Assuming they're all equally right. So, and is blank to 0, is it? Not equal. Yeah, thank you. I was having a little hard time. Not equal. Not equal to 0. It's not equal to 0. What does that mean about mutually exclusive? Yeah, not mutually exclusive. So if this was equal to 0, we could tell that means these are mutually exclusive events. It has no effect on it, right? So one excludes the other. Right? So that's how we can tell. We can make that statement too. That A excludes B. Yes, for mutually exclusive, if they are mutually exclusive events, probability of A and B is 0. Straight up. So that's how we can define it too.
It's a good song.
So A and C do not have any numbers in common. So A and C equals 0. Did you get that? So they are mutually exclusive. Therefore, A and C are mutually. I'm just going to put ME because I can't spell. I mean,
It's hella
because
long too.
it's too long to write.
Yeah.
That's it.
Not enough space.
There you go.
So, right, since A and C have nothing in common, C is down here, 7 and 9, not in A at all. There's no overlap. I can't even write the set of A and C. So there's nothing in common, so there's no way to get A and C to happen. So are mutually exclusive events dependent or independent? So mutually exclusive events, this is a weird thing, I'll write out the full word here. Mutually exclusive events are actually dependent.
That's what I was thinking. That makes sense.
Are dependent event. So because it changes the probability, and it doesn't work backwards, it doesn't work anywhere else. I can't say dependent events are mutually exclusive. That's not true. We'll see some examples later on. It's really just mutually exclusive events are dependent. That's the only case we have. So like in this case, so we have mutually exclusive event A and C, right? Because if I pull one out of here, right, and it's a 5, that's an A, right? 5's an A. So I know it's a 5, that changed the probability of getting that 7. Not on the second roll, on that roll. They're mutually exclusive, they're also dependent. Because they're mutually exclusive. If that helps you think about it. So not a big deal if you don't get this, but let's move on. So flip 2 fair coins, find the probability of the events. Let F equal the event of getting at most 1 tail. So I'm flipping 2 coins, so what is this space? F is the event of getting at most 1 tail, so. Oh wait, I guess I should
2 coins, right?
come up with my sample space. I didn't come up with my sample space.
Sorry.
So I flip 2 coins. What are my possibilities? I could get like heads,
HT.
tails, tails.
TH.
What, TH? Heads, tails, so like that. So it doesn't matter what order we put it in, we just have to make sure we get them all. Here, in this case there's only 4, but if I bump it up to 3 coins, then it gets a little more confusing about how we're making sure we get them. It's a counting principle that I don't think we're going over this, unfortunately. All right, so F is the event of getting at most 1 tail. So, right, this one has at most 1 tail, this one has at most 1 tail, this one. Let me use green. Green,
Yeah.
and green, all right. All 3 of those. The only one that doesn't have 1 tail is the heads.
HH.
So all, yeah, go
You
ahead.
can't use telltales, can you? It says 0.
At
Oh,
most,
that's true. Boom. Yeah. So it's only, yeah, there you go.
You didn't hear that? I meant, yeah, this one, see?
Erasable
I totally
pens.
had it, oh, dang it, didn't erase fully.
Oh, that's right.
I totally made the dreaded mistake of thinking about at most, right, versus at least,
Okay, so.
right? So that is a dreaded mistake that happens a lot in this class, because if I say at most, that means the maximum I can have is 1, right? Or if I say at least, that means the minimum I can have is 1, right? So watch out for that. It's easy to make that mistake, as I just
HHT,
did
TH.
myself. I was just testing you to make
Right,
sure you're
making
awake.
sure we were
Good job,
all
Jasmine.
there. So HHHT.
So right, so TT isn't included, but HH is.
Cool.
So we got HH. Whoa, why did I write it so big? I don't know.
HT and TH.
We got those 3 things. So we don't ask the probability here, so let's move on.
That's
Sorry.
it?
Does this say tail, to get 1 tail?
1 tail, at least, at most 1 tail. So I can't, 2 tails, right? Doesn't happen unless you're watching the
What's
Sonic
the
movie.
HH? Oh, 0. Oh,
I
my
know,
goodness.
jeez.
I got it now.
PT.
Yeah, Jasmine.
Some of us haven't
When it
understood.
says example three, it does say find the possibilities. Do you want us to do both? Like F equals whatever and find the possibility?
I didn't see that. Let's just, let me just look at the
Where
next
does it
page.
say find the probability?
It does say that, yeah, so find the space, flip 2 fair coins, and find the probabilities of the events, okay,
So we write
thank
the
you.
what out of what?
So, yeah, so what is the probability of F?
3 out of 4,
Yes.
right?
Right, these are just one event.
Oh, just-
I have 4 events here,
3 out of 4.
alright, and I have 3 of them in there.
So P.
So kinda like that ordered pair things, even though I have 2 letters up there, it's really just one event.
So
in
P
each
of
of those 2 letters.
is equal to 3 over 4. Sweet. Okay.
Alright.
So that G, the even.
So G is the event of getting 2 faces. So G equals 2 faces. What were my 2 possibilities are?
2 of 4.
So what's that?
2 of 4.
Oh, you can't see it. But what's wrong with that? So we have 2 faces. So so it's kind of confusing because right, you might think the heads is the only face you get, right? But they also have
Doubles.
tails as a face. So
Alright.
it's just you're talking about the same. The outcome's the same. Either heads or tails.
Right.
Is what they technically mean here. So we have those 2 possibilities. What is my probability of G? 2 out of 4. questions about that? Let H be the event of getting ahead on the first flip by following a head or tail on the second flip. So the first flip has to be head. I don't care what the second one is. First one has to be head. I don't care what the second one is. What are my possibilities for the second one? H.
Head, tail.
All right. Yes. All right. So I'm trying to show you right now. I'm figuring this thing out. What it's saying. We have a possibility heads or heads tails.
Right.
First one has to be a head. That's the only thing. Stipulation. What's the probability of that?
2 or 4.
Probability of H is 2 over 4 again, or 1/2, or 0.5, or 50%.
So that's P of H.
So, mutually exclusive events, how do we tell something's mutually exclusive?
They don't have anything in common.
No, they don't have anything in common between them. We can also check the probability of F and G to see if there's anything, right, in there. So I don't have F in front of me. F was
F is 3 over 4.
what was that? We had 3 though.
Oh, yeah.
We had
H, T, H.
H, T, T, H.
Yeah.
So there's my F. All right. Do F and G have anything in common?
H.
H. My probability of F and G is 1 over.
4.
So I'm just calculating that probability. Is that equal to 0?
No,
No. What does that mean?
it's not mutually exclusive.
So not equal to 0, not ME. You can say no. I think I might need that justification though, right, that it's not mutually exclusive, or you can use words and say there's nothing in the same sets, Andre, you're right. There is something in the same set, so they're not mutually exclusive. If there's nothing in the same in these 2 sets, then that means they're mutually exclusive. Nothing in common.
Sweet.
So let the J equal the event of getting all tails, so that would just be tails, tails.
Right, so
Are J and H mutually exclusive? So the P of J and H, or I can just look, like many of you said, is there anything in common between J and H?
no.
No, so the probability of J and H is 0, which implies mutually exclusive. I could say yes, they are, whatever. No, they're not. Many ways you can describe that to me, I don't care. Just describe it to me some way, shape, or form. Don't just say yes or no either, you have to justify it some way. So, formula is pretty easy, right? So use the formula, that would be the best, I think. Clearer rather than using words. Sometimes it's harder to explain with words. But if you forget the formula, then hey, try and use words, right, to explain it. I did have some people on the last test explain to me the ideas of was it cluster or sample, I forget, to try, and they actually, instead of just circling the ones, they circled it and then explained what they meant, because it was a little, some of them were a little confusing, right? I was trying to see if you really understood it. So some people actually explained right next to me, and actually I gave them the points even though they might have been wrong, according to what I wanted. So they were actually able to explain what they meant and explain it in the proper way. That's what I'm saying. All right. So, questions about that one? What time? 11:10. Okay. So, example 4. Roll 1 fair 6-sided die. Sample space is 1, 2, 3, 4, 5, 6. Let event A equal a face is odd. So here we have event A. The event B is the face is even. So those spaces are, I don't want to say it because we're asking that right here. Find the complement of A. So we want to find the complement of A, which would be Everything B. Yeah. Everything in B. It's the opposite of A. If A is all the odds, then the opposite of A has to be all the evens. So this complement of A is actually B. Let's C equal the odd faces larger than 2, so what would go in this set? 3? That's it? Larger than 2, 5? Yep. Anything in here, right? Anything in our sample space that is odd and above 2. So 3, 4, 5. How about D? So we got 3, 5. Let me underline them. All even faces smaller than 5. D equals smaller than 5. All faces smaller than 5. So all even, sorry. I missed that even part. Ah. 2 and 4. So 2 and 4. How about the probability of A, C, and D then? Good. What does that mean about C and D? They are. They are, yeah. They, why didn't I put there? They are ME. Let event E equal all the faces less than 5. So what would be in that group? Yeah, just less than 5. 1, 2, 3, 4. That's it. Are C and E mutually exclusive events? C and E. E was, oh, E's here, C is here. Are they mutually exclusive?
No, sorry.
There is something in common, so probably not, right? Because our probability of C and E, a little bit easier to talk about here, is technically we got the 3 in common, so 1 out of, I have one thing out of a total of 6, which is not equal to 0.